We're going to pick up part 2 of chapter 1 with talking about an ecological footprint, or sometimes called a carbon footprint. It's a measure of how much a person consumes expressed in an area of land. It helps us calculate sustainability and looking at the impacts of our lifestyles and our activities. If our lifestyle demands more land than is available, then we are living unsustainably. And this is a diagram of an ecological footprint. So things that we want to take into account is how much energy, the settlements, the timber and paper, the food and fibers, the seafood, the fisheries, the cropland, forest, built-up land, carbon footprint, all of these things that go into things that we need to survive. So our house needs timber, and how much land does that take up? How much land does it take up to feed us as an individual person? How much land does it take up for the energy that we need to be provided? And all of those things factor into what's called our ecological footprint. Looking at today's statistics, the present-day footprint of global human population, and if all people had the same lifestyle that we have in the United States, we would need 5 Earths to support that lifestyle. We live far more unsustainably than other parts of the world. We are using far more resources than we are allocated. And if everyone lived like us, it wouldn't be possible. Let's take a quick look at the scientific method. We're going to go through this kind of quickly because we've done this before in a lot of other science classes. What is the scientific method? It's an objective way to explore the natural world, to draw inferences from it, and to predict the outcome of certain events and processes or changes. The steps are the ones that we've looked at before. Observations and questions, form some sort of testable hypothesis or prediction, collect data, conduct an experiment, interpret the results, and then disseminate the findings. Observing and questioning is the first step. Observation leads to a question. And then this important idea of a hypothesis. So this is usually new to environmental science students. And a hypothesis is a testable guess about how something works. So what's an educated guess that can be proven or disproven through a controlled experiment? This is different from a null hypothesis, which is a statement or idea that can be falsified or proved wrong. It's used when it's easier to prove something wrong than it is to prove it is true beyond doubt. An example of a null hypothesis is fish deaths have no relationship to something in the water. So likely they do have some sort of relationship, but it's easier to prove the null hypothesis. When we collect data, we're looking to make sure that we repeat the measurement many times, that we have an adequate sample size, that we're using proper procedures, and that things are both accurate and precise. Accurate is how close a measured value is to the actual or true value. Precision is how close the values are to one another. And then uncertainty is how much the measure differs from the true value. This is the same image that you probably saw in chemistry. If it has low accuracy and high precision, they're very close to one another, but to be precise, they have to hit the target. The next one has, it says it has high accuracy and low precision. I wouldn't define that as high accuracy because I don't feel like those targets are very close. I would feel like that's low accuracy and low precision. But the last one, they're all fairly close to the bullseye, and they're all fairly close to one another, so they have high accuracy and high precision. When we interpret results, we can interpret them through graphs, summaries, charts, and diagrams, and these are all ways that we're going to interpret results this year in class. It involves 2 types of reasoning, both inductive and deductive. So inductive reasoning is the process of making general statements from specific facts or examples, and deductive reasoning is applying a general statement to specific facts or situations. And we can only accept or reject certain hypotheses based on what the data shows. Then when we go to disseminate our findings, it's based on many experiments. Scientists present papers at conferences and allows other scientists to repeat and verify the challenges. And then scientists have to obtain the same results multiple times, and then they're considered valid. Critical thinking is questioning the source of the information and the methods used to get the results and draw your own conclusions. Next comes a theory, which is a hypothesis that has been repeatedly tested and confirmed by multiple groups. And then a natural law is when a theory has been tested multiple times, and there are no known exceptions. These are things like the law of gravity and the laws of thermodynamics. The next idea we want to look at that comes specifically to environmental science a lot of times is controlled experiments and natural experiments. And so examples of scientific method application. In the 1990s, scientists expect that organophosphates may have a serious effect on the central nervous system. And the focus is on chlorpyrifos because it's a widely used pesticide. So a controlled experiment is an experiment conducted in the controlled conditions of a laboratory. And the controlled experiment that was done on these organophosphates was on rats. And one group of rats was just given normal food, and the other group of rats was given food that had the organophosphate pesticide on it. And then they could measure the enzyme activity to see if there was an impact on those mouse. It was controlled because we had a control group and we had an experimental group, and we knew what the variable was. A natural experiment is when a natural event acts as an experimental treatment to an ecosystem, and some difficulties in data interpretation can arise. Looking at a volcanic eruption, a volcano causes a large-scale study of forest regrowth. It's important because we're not going to just go ahead and say, well, what does it look like when a forest regrows? We're not going to go ahead and mow down a forest so that we can see what that looks like. But if it happens naturally, it gives us an idea so that we can watch and see how that forest regrows. There are some challenges with that in terms of we are not controlling all of the variables as specifically, but it does give us some ability to study different things that happen in the environment. Experimental science presents unique challenges. I think that's supposed to be environmental science presents unique challenges, because it definitely does. There's no control planet to compare the Earth with. So if we're looking at, environmental systems and why they are so complex, it's difficult to decide what is better or worse for the environment than something else. Environmental science has so many interacting parts, it's not easy to apply one system to another. And human well-being is a concern because people that are unable to meet their basic needs are less likely to be interested in saving the environment. If you can't meet food and shelter and water, you're not concerned with recycling and living sustainably. You're concerned with providing those basic human needs. And then we start looking at environmental equity and environmental justice. This lack of baseline data is that there's no control planet, and every part of the globe has somehow been altered by humans, and it's hard to know what the original levels of contaminants or certain members of species. And environmental systems are complex because they involve subjectivity and interactions that are complex, and human well-being is a factor. If we're looking at examples of inequalities, recycling circuit boards is often done in developing countries. And these developing countries do this. There's a high exposure to pollutants and toxins by doing this. But these people are looking to make money and to raise funds, and it's a job that pays more than what they might have an option to, so they take on that risk. Whereas looking at this inequality, people in a developed country may choose not to have this sort of job. So that's the end of Chapter 1. And I hope you got a good feeling for how this Edpuzzle and note-taking is going to work for us for this year.